Hey guys, I am Gautam and welcome to Chemics. In this video, I am going to talk about the last 5 years question papers of IIT JAM chemistry examination of the chapter Stereochemistry, right? So, the first question from JAM 2014 was, which one is chiral? So, you can see the question on your screen. So, in case of option A, the two option A like this. Okay, so here 2 Cl atom is attached with same carbon atom, that is no nomenclature is possible, that is it you cannot be determined as it is chiral or not, so it will not be chiral. Now coming to option B. Option B is, in case of option B, the system is like this. So all the atoms connected to the two carbon atoms are on the same plane, but to determine the chirality, these two, at least one carbon atom should be present in the different plane, right? So this is not chiral. So the next option C, which is like this, actually like this. This is Cl, this is ACE, this is Cl, and this is ACE. So the two system is different, and here also the two system is different, and also this is one plane, this is another plane. So this is to be chiral, right? And in case of option D, of course, this is a biphenyl system, and all the groups are also in the same plane. That is why this is not possible. This should be on the different plane, and that is why option C is correct, right? So how to determine the chirality or the RS nomenclature of this kind of system, I have already made a video, so you can check over there by clicking the I button, right? So next, coming to JAM 2015. The question was the structure of 2S3R 2-amino 3-hydroxybutanoic acid is. So you just need to determine the structure of 2S3R 2-amino 3-hydroxybutanoic acid, and which is to be finally like this. Above CAA is below CH3, and here this is like this, and sorry, there will be NH2 over here. O is ACE, right? So you should determine this kind of system, the RS nomenclature. So already I have made another videos for this, so you can check by clicking this I button, or you can check the previous videos, and in the same video you will get both the nomenclature, right? So the final answer will be this, and the final option will be right 3 or option C, right? So this will be S and this will be R. So this is 2, this is 3, 2R, 2S, 3R, right? So this will be the correct answer. Next, coming to JAM 2016. Okay, so the question was, which one is most stable? So you can see the question on your screen, and in case of A, Br, Me are on the consecutive manner. That is why the repulsion is much more. In case of option C, Br, Me, Br, the same case. In case of option D, Me, Br, Me. So here is also the same case. But in case of option B, you can see that the two same group are on the opposite side. That is why Br opposite Br, methyl opposite methyl, hydrogen opposite hydrogen. So this system is the most stable system, right? So option B will be the correct. Okay. So this type of question you may face in IIT JAM 2019 also, or maybe 19, 20, 21. So the question is not that much tough as you may think. Okay. Next, coming to JAM 2016 second question, that was the number of all possible isomers of molecular formula C6H14. So C6H14, that is, it should be alkane, because it follows CN H2N plus 2 rule. If N equals to 6, then it will be 14. Okay, so it is alkane. So the number of all possible isomers, so it is a class 10 type questions, class 10 or 10 class 11 type questions. So it is very easy. You should know the answer, but I am considering it like this: 1 2 3 4 5, 1 2 3 4 5 6. This is one isomer, another isomer, another isomer, another isomer, and the last one is like this. Wait a second, just okay. So this type of total 5 isomers are possible, and this is the final answer. So this question is very easy. Next, coming to next question from JAM 2016, that was the number of molecules having C2. So you can see a lot of molecules are present, and you just need to find the number of molecules that have C2. So in case of first molecule, that is like this. So it has C2 here. The C2 is present, so you can rotate like this. Okay. Next, coming to option like this. So here also, if you put like here and rotate 180 degree from holding here, then you can easily get the same structure. So it has also C2. Next, coming to this structure, there is Cl, Cl, H, H, and the C2 axis will be like this. Okay, so and you will get the same structure. Then coming to option 4, that is Me, Me, and this is Me, Me. Okay, you can see on your screen the videography that this also has the C2 axis of symmetry, right? So next, coming to BF3, that is like this, and here from here 3 C2s are present. Next, coming to systems like CaCl3, that is AClCl. Here no C2 is present because C3 is present right here like this, but here no C2 is present, so this will not be this will not have any C2 axis. Okay, so next, coming to another example, that is system like this. So here also C2 is present like here. If you rotate like this, then this will go right here and this will come right here, and C2 is present right here. And in this compound also you will find C2. Okay, so it is like the previous one, that is this. So you can see on your screen the digital rotation, right? So thus it has also the C2 axis right here. So the total number of molecules which have C2 axis are 6. Total number of molecules are 7, except this one, everyone has the C2 axis. So total number of molecules will be 6, and 6 is the correct answer. It is the fill in the blank time question, and 6 is the correct answer. Okay. Next, coming to JAM 2017. The question was, which one have C3 axis of symmetry? You can see the question on your screen. And in case of first, you can hold like this. I am holding the pen, and you can rotate like this. Okay. So, and you will get the C3 axis. It will come right here, it will here, and it will come right here. And thus it has C3 axis. So option 1 is correct. So you just need to find the option in which option 1 is present. So A, B, and C options are possible. D has been deducted. D has been rejected. Okay. So now in between A, B, and C, you just need to check B, option 2. Second option is like this, right? So if you rotate like right here, the C3, that is 120 degree rotation, and you will not get the same structure, because every structure is not like 60 degree or something like that, because it's a 5-member ring, so you will not get the same structure. So that is not possible. No C3 is present. In case of option C, like this, BR, and the angle is 120 degree. So if you rotate by C3 axis, this bond will come right here, and this bond will go right here, and this bond right here, and thus it has C3 over here if you rotate like this, like the previous one also. Okay, and the final option D, which says this one, above group and below methyl and below methyl. So you can easily understand that holding here, you will not get the same structure if you rotate via C3 axis. Okay, because these bonds are in the below side, so this will be below. These two will be interchanged, but when this will go right here, this above bond will not be found. So this is not possible. So the final answer is A, that is A and C, that is option C, that is 1 and 3 are correct. Okay, so option C is correct. Next question of JAM 2017, and the question was, catalytic hydrogenation of the following compound produces saturated hydrocarbons. The number of stereoisomers found. So the compound is like this one. Okay, so here. Okay, here here is methyl. So if we do catalytic hydrogenation, then we'll get the alkane, total alkane. So the final alkane will be this double bond and this double bond will be reduced, and finally we will get like this structure. And in case of this structure, there is one chiral center and there is two chiral center. No other chiral center is possible, right? Because one group, another group, total group, and another group, and other is hydrogen. So 4 different groups should be present, and for these two center, 4 different groups are possible. That is why 2 chiral centers. Suppose this is chiral center A and this is chiral center B, and A B. So if A has R configuration and B have S configuration, or A has S, B R, or R S S. So for this one stereoisomer, for this another stereoisomer, and for these two are same actually, because both side have the same configuration. So from this one configuration, so 1, 2, 3, total 3 stereoisomers will be present, and 3 is the correct answer, right? So coming to next question, the total number of pair of enantiomers possible with the molecular formula C5H12O, which will be the final answer. So the answer will be like this: pair of enantiomer. That means you should have the structure should have chiral centers for this formula, right? So the different kind of options will be like this. I am drawing the different options. Okay. So the first possible option or structure will be like this. Second structure will be like this. Third structure will be like this. And the fourth structure will be like this. So here this is the chiral center, here this is the chiral center, this one and this one. So 4 chiral center in these 4 compounds are possible. So 4 compounds will form 4 different enantiomers. So this will form a pair of enantiomer, this will form another pair, and finally this will form another pair of enantiomers. So therefore 4 pair of enantiomers are possible, right? So final answer will be 4. Okay. So next, coming to JAM 2018. The first question was, among the dimethyl cyclohexanes, which one can be obtained in enantiopure form? Here enantiopure form means which has enantiomer. That means if a system has sigma plane, that will not have any enantiomeric structure or any enantiomers. So we need to find the system which doesn't have any kind of sigma plane. Okay, so in case of A which is like this, that is, it has 2 methyl group in the equatorial form. So here I need to add something. If you need to understand this kind of cyclohexane systems, how to draw normal cyclohexane like this from this kind of system, you just need to watch this video by clicking the I button. So I have already made a video, so check there and your confusion will be totally cleared, right? So first, if you are unable to understand, then you can first watch the video, then continue. So first, this 2 is equatorial, that is EE, which is equal to trans 1,2. Trans 1,2 means suppose this is above and this will be below methyl, right? So this system has no sigma plane and you will not find any sigma plane. So this will be the correct answer. I am considering another example. Let's take option B, which is like this. I am just want to show you the sigma plane in this system. So this is axial, this is equatorial. So A system 1 to A, that means cis system, that is 2 methyl group on the suppose above side. So there is a sigma plane like here. So it is a sigma plane and you will get the same structure on both the side. Okay, so this has the sigma plane, and that is why it doesn't form any enantiomer. Okay, so you cannot find this molecule as enantiomer form, right? So this will be the correct answer, and other 3 you can check other 3 options by converting those in this kind of structure by C system. Okay, I hope you have already remembered AE system, which I have told already in my previous video. So okay, so you just need to check. You will get the link in the description. So check the video first, and then your confusion will be cleared, right? So next, coming to next question. The next question was, on reaction with NaNO2HCl, which of the following amino alcohol will yield compound P? And the compound P is like this, and here CHO. So from cyclohexane you need to prepare 5-member ring, that is ring contraction. So ring contraction is possible when pinochle. You have already remembered that I have already solved this kind of question, so you can check by clicking the I button and you will understand what I am trying to say. So you will get the 5-member ring structure from 6-member cyclohexane, substituted cyclohexane. So how can you get that? So I am giving you the examples. In case of option A, this is like this. So it's a biased totally locked system, because this is a bulky group. It cannot be towards the axial direction. So it is always locked. So the system is locked. That is when I am treating with NaNO2HCl. So NH2 will be N2 plus Cl minus as a leaving group, and here option O is. So this kind of rearrangement. So this is leaving group. So we need to find the another system, another bond or another group which have anti to this leaving group. So anti leaving group, this one. So when this bond will break, this hydrogen will go like here, and this will detach the system, and finally we'll get. So it's already a 6-member ring. So this is not possible. Next, coming to option B. Option B says like this. And finally, this is N2 plus Cl minus, and here O is. So this is leaving group. So we need to find the antibond. That is, antibond means this parallel bond, of course. So first this will break, and then this bond will shift towards here, and this will detached. This will be detached by this bond. Okay, then 5-member ring will form another one, and then another will be CHO. Okay. Similarly, from option C, you will get the same, this one, and option D, you will get nothing. Okay, so option B and C is correct. This is the MSQ type question, and option B and option C is correct. Okay. So next, coming to question number 44, that is in JAM 2018. The number of stereoisomers possible for this. And here also O is. So it's very easy. This is the chiral center, this is the chiral center. And if this is R, and this will be R, one set of stereoisomer. There is one isomer, of course, same molecule. This will be S, this is S, another stereoisomer. This will be RS, or this will be SR. So both are same actually, because this is a symmetrical molecule. So 3. So there will be total 1, 2, and 3. 3 stereoisomers possible for the system. And the last question coming from JAM 2018, for which you need to determine the number of configuration having S configuration or S nomenclature, right? So I have already made a video. You just click the I button and you will get the video, and first watch the video. And if you are unable to understand the RS nomenclature of biphenyl, then alene system or something like that, or different kind of system which have stereo centers, so just first watch the video and then continue to watch this video. Okay, so the first option, this one, will be S. Actually, the first option will be S. The second will be R. The third, the alene system, will be S. The fourth will be S. The fifth will be S. So total, except the second one, all of the system will have the S configuration. So there will be total 5 system, and except one, there will be total 4 system which have the S configuration. That is why 4 is the correct answer, right? So that's all, and I will also provide you all the solutions of these in my blog as a PDF, so check over there. And also some important topics I will also add along with this kind of examples, okay, which you need to read from Stereochemistry. So if you have any query, if you want to understand any topic, just comment below. I will definitely try to make a video. Okay, so thanks for watching.